Okay, so we are now into part 3 of 3.5. So you guys got to understand that 3.5 is a very crucial thing to understand moving forward. Lots of other chapters and even 20-1, 30-1, 20-2, and 30-2. This is kind of some foundational knowledge you got to understand. Now, using algebra tiles, you will just see this kind of in grade 10. I'm going to quickly show you how algebra tiles kind of help us visualize factoring. So we just learned how to factor all different types of polynomials where the coefficient, the leading coefficient, is +1. Now remember, the leading coefficient is the number in front of the largest variable with the largest exponent. So at the moment, we just know how to factor where it's a +1. And sometimes we have to factor things out. Like here, we factored out a 4. Here, we actually don't know how to deal with this yet because we can't factor 5 out of 6 here. Anyways, we are now, how does this algebra tiles kind of help us visualize factoring? Okay, well, the first things we got to understand is that there's a small length, okay? So if we have like a small length of, let's say this length, this represents +1. Okay, long lengths represent x. And then you can kind of put those together. So if I have a small length here on top, this is +1, and then a long length here, this is x. So this represents 1x, okay? You're doing 1 times x. It's the area of this shape, okay? And these tell us what the side lengths are. So here we could have a long length on top, so this is x, a long length on the side, so this is x. So the area that we can create from this triangle is x times x, which is x squared. Okay, now here we can sort of visualize, here we have v squared, 3v, and 2. So what does that look like? Well, here if we kind of lay that out, that means we have one big square, okay? What else do we have? We have 3 long lengths. And then we have 2 cubes. Okay, so this is, remember, like 3v represents these tiles. Now, let's factor this thing out and see what we get. So again, we're going to have to PSA it. So my product is my constant because it's a variable of, or a coefficient of 1 here. So this is just my constant is 2. My leading coefficient would be +3. Sorry, my sum, okay? Now, what numbers multiply to 2 and add to 3? So remember, these are some numbers that multiply to 2 and those same numbers that add to 3. Well, here I know that 2 times 1 equals 2. 2 plus 1 equals 3. So it looks like A could be 1, and then B could be 2. So we know that we will have V plus 1 here and V plus 2. Okay, so here, something that we can recognize is we can represent this as one of the side lengths, and this guy as the other side length. So here, I'm going to do v plus 1. What is v plus 1? Now remember, these lengths tell you how long they are. So here it'll be v length, and then a little 1 there. Okay? Now, this guy on my other side will represent v and 2 here. Okay? So the long length for v goes down, and here we can see that we can create a rectangle. So this would be v squared, and then this is v times 1, and remember that makes this side length v, so we get a skinny one, and this represents v. Here we have 2 short lengths on the side, and we have a short length with a long length on here, so this we get a tile. So there's v, and then here we get a tile, and that gives me v. And then now we have 2 short lengths on this side, short, and then 1 long. or sorry, 1 short as well on the top. And these make little 1 by 1s. So this is 1 and 1. Now recognize we've just rearranged this into a rectangular shape, okay? And we've represented the factors of this. So we can see that there's 1v squared, there's 3 v's, 1, 2, 3, and then there's 2 single units, 1, 2. V plus 1 is represented on the top, and V plus 2 is represented on the bottom. So here's our factors, and then from here we can show the entire trinomial. Okay, so we've taken this and rearranged it into a rectangular shape. What about this one? What does this represent? Well, this represents an x with 3 single units, so this represents plus 3. This is x on this side because it's a long length. And then this would be 3 single units, so plus 3. So here we have what? This represents, in factored form, x plus 3 multiplying x plus 3. Okay, we could also figure out the trinomial it represents. So this is x squared. This is x and x and x. This is also x and x and x. So far we have x squared plus how many x's do we have? 1, 2, 3, 4, 5, 6. 6x. And then how many single units do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be plus 9. Now recognize if we expand this out, so I'm going to do x times x, which gives me x squared. Then I will do x times 3, which gives me plus 3x. And then I'll focus on here. 3 times x gives me 3x. 3 times 3 gives me 9. And then I can combine like terms. Both of these values have x's, so I get x squared plus this creates 6x plus 9. So here you can see that algebra tiles can be very, very useful, okay? So just remember how these, there will be a few questions that talk about algebra tiles. Just recognize it is a tool to understand what factoring kind of looks like visually for a trinomial, okay? So please now go and try out AFL 3.5. Hopefully you've been practicing all these other ones as you've been going along, just in your textbook questions and stuff like that, because this is a very crucial unit to understand. This whole chapter is super important. So make sure you're coming in and asking lots of questions, because I can't go through every example in the world, and at the end of the day, it's up to you to make sure you're practicing and asking those questions so we can clarify certain things that you don't understand. So go and check your understanding with AFL 3.5.